There's a problem up on the board here. I'm going to suggest that you pause the video and try to work this one out on your own. Once you've worked it out, turn the video back on and we'll work through it together so you can check your work. Welcome back. That's my very official way of having you pause the video. Very low tech. Okay, let's see. If I try to plug in 1, I can't, because it's going to make the bottom go to 0. See what happens on top. If I try to plug in 1, I get 2 minus 1 minus 1. That's also going to 0. So this is an indeterminate form. Okay. Now here, I think I'm going to want to try both techniques that we've discussed. The top here is a polynomial, so I think I'm going to want to factor that. The bottom is going to 0 and it involves a root, so I think I'm probably going to want to try to rationalize that. So let's see, limit as x goes to 1. Now one thing that's nice with this factoring, I know since 1 makes the top 0, that x minus 1 has to be one of my factors. That's something we know about polynomials, that if a number makes that polynomial 0, x minus that number is a factor. So not that this is super difficult to factor anyway, but I'm already halfway there. So I can see, in order to get 2x squared for my lead term, I'd need 2x. And in order to end with a negative 1, I'd need a plus 1. Quick check. Let's see, 2x squared plus x minus 2x is minus x minus 1. Nice. All right, then on bottom we've got the root x minus 1. I'm going to rationalize that. So I'm going to multiply this whole thing by 1 in the form of root x plus 1 over itself. So this is going to equal the limit as x approaches 1. Now on top, I'm going to just keep this in factored form. X minus 1, 2x plus 1, root x plus 1. I only want to multiply things out if that's going to make things look nicer. On top, right now this piece has roots in it. If I distribute it, the other pieces are going to have roots too. That's going to make them look more complicated. On bottom, on the other hand, if I FOIL, I get root x times root x is x. Outsides and insides cancel. Last terms are a minus 1. So now I can see this is great. I can just cancel those x minus 1s. And so I can say this is the limit as x goes to 1 of 2x plus 1 times root x plus 1. This function is different from the function that I started with because it has a different domain. This function was undefined at 1. This function is defined at 1. But they're the same everywhere except at 1. So the limit as we approach 1 is the same. And now for this limit, I can evaluate it by plugging in 1 for x. So that's 2 times 1 plus 1 times root 1 plus 1. See, that's 2 plus 1 is 3. Root 1 is just 1, plus 1 is 2, and 3 times 2 will be 6. So this limit simplifies to 6.